Alright, so now we're talking about relations. This is our next topic here. A relation is just a set of ordered pairs, or basically what it does is it takes a group of numbers and assigns and matches each number from one group to numbers in another group. So there's several ways of representing this. One would be a set of ordered pairs. So this matches 1 with 1, 0 with 2, and 3 with -2. So the domain are your inputs. Alright, I need to define these before I can really talk about the rest of this. The range are the outputs or the results. Okay, so the domains are also called your independent variables. And then these would be the dependent. So here our inputs, or our x's, are all 1, 0, and 3. So our domain here would be just the set 1, 0, 3. And typically we would like to write it like this, in numerical order, not just the order they give it to you in the table. And then the range would be -2, 1, 2. So I went in order from least to greatest. So the domain is a set of inputs, the range is a set of outputs. So one way is to just make a table of them. It's just these numbers in a table. Another way is to list the numbers, and typically what we would do is do them in numerical order. So we would do 0, 1, 3, -2, 1, 2, and then match them correctly. So that's 0 to 2, 1 to 1, and 3 to -2. That's really how the mapping should look. Alright, so it just tells you this input goes with that output. Those are just the different ways. This is our x-axis and our y-axis. So this says when x is 1, y is 1. So that represents this input. So they're just different ways of showing different things, and different ones are useful for different reasons. So if this is a relation, our inputs are -2, 3, and 4. So that's -2, 3, and 4. That's our domain. And we use the squiggly brackets typically for sets of numbers. So -2, 3, and 4. -2, 3, and 4. Now our output, or our range, is -1, 3, and 3. So -1 and 3. We only put what numbers they are. We don't write them numbers multiple times, right? So if there's a 3 here twice in our relation, 3 is just one number, so we just write the number 3. This is telling us which numbers are in our range. So -2 goes with -1, 3 goes with 3, and 4 goes with 3. So we'd have a -1 and just a 3 here. Alright, so there's less numbers, there's less different types of numbers in the range and the domain. That's fine. So -2 goes with -1, 3 goes with 3, and 4 goes with 3. To graph them, you've got to have both numbers to graph them here. So -2, -1, 3, 3, and 4, 3. That's it. That's expressed all different ways. Now, if I give you a graph, you should be able to write the mapping, the table, and the mapping, the set, and the table. So you should be able to, given any one of these, get the other 3. So an independent variable is also known as the control variable. So if you're doing an experiment, the independent thing is the thing you can control. All right, or it's also the one you are free to choose. So think independent, think independence, freedom. You're free to choose variable. The dependent is just like it sounds. It depends on the independent variable. So usually it's easier to figure out what depends on what you say. This depends on that. So that means that this is the dependent variable. Once you know the dependent variable, then you know the independent variable. It's just the other one. So identify the independent and dependent variables. So this graph represents the height of a football after it's kicked downfield. Identify the independent and dependent variable, then describe what's happening in the relation. So time is going to be our independent variable, and height is going to be our dependent, right? Because the height of the ball depends on how long it's been traveling through the air. So as soon as you say the height depends on time of travel, you know height is your dependent variable. So then what's happening in the graph? It's initially starts at a height of 0. It's kicked, and as it's traveling through the air, it's getting higher and higher until it peaks. At some point it reaches a peak, it's peaking, it starts coming back down again until it's back on the ground. All right, so that's what's going on through the graph. Typically you would write this here, but since I'm talking to you, I can just say it. This represents the price of stock over time. Identify the independent and dependent variable and describe what's happening. So the price depends on time here. Time is almost always the independent. Not always, but usually it's the independent variable. And basically this is just showing that as time goes on, our price had a certain value. A little time later, so we don't have a scale here, so we don't know whether this is minutes or hours or days or weeks. But after a certain amount of time, the stock went up to a certain peak, then it fell, and then the stock rose slowly. Notice it went up a bigger amount in a shorter amount of time here, and it went up a smaller amount in a longer amount of time here. Right? So even in a longer amount of time, it went up a shorter amount, but it peaked at a little bit higher. All right, so that's what's going on. Peacock spiders. You ever seen a peacock spider? Scary. Ooh, that was scary. Here's your U-try. So, given the set, represent the ratio in the other 3 ways, and then describe what's going on in the graph here. Identify the independent and dependent variables. See you next time.